Welcome to Boring Astronomy. I'm Alessandro, your astronomer next door. And today we interview Maria Luiza Dantas, and we're going to speak about galaxy evolution, data science, meta science, and perhaps cats. So,
Yes.
Maria Luiza, welcome.
Hi, Alessandro. Thank you for having me here today. Thank you for the invitation. It's very nice of you for considering me for this.
Boring astronomy. So, there's something that I really like to do with guests, and that is I don't introduce guests. I ask the guests to introduce themselves. So, tell us something about yourself.
Okay, so I'm currently a postdoctoral researcher here in Chile, in Santiago, Chile. This is officially my third postdoc. So I mostly work with galaxy evolution, galactic archaeology, and especially stellar populations in both resolved and unresolved regimes. So I'm basically interested in all astronomy, to be honest, and I hope by the end of my career I have a paper in each field. I'll be happy with that. And maybe, who knows, some papers, about dinosaurs and stuff. I would be happy to collaborate with those people, maybe using some fancy techniques, and then I may have, a paper with dinosaurs and stuff. I love that.
So, let me start asking something, something I'm curious of. How do you decide what projects to pick up?
Okay, do you mean in terms of how? I mean, how I've chosen them throughout my career, or
Yep.
how do I do them now?
Both.
Okay, so when you're very young, you don't really have a choice. So you do what your supervisors have. They have some projects on the side, they have ideas, and then when you're like an undergrad or you're doing your master's, you're really young, you don't really get a choice. And most cases, that's also the case for PhD students. They hop on other people's projects and they don't have the opportunity to do that, to do their own project, which is understandable because these people, they don't have the experience yet to know what's cutting edge in astronomy and what you can really research that has not been done yet or not been properly done yet. So that's the first thing. So in my particular case, that I had not had the choice of to choose my research projects when I was an undergrad and when I was doing my master's. But that changed during my PhD because with the experience I had with my master's, I
What did
approached
you do
Paula
your
with a
undergrad?
project.
What did you do your undergrads and your?
Okay, when I was an undergrad, I had a project in radio and infrared, in star clusters. But honestly, I didn't learn much. Not much came out of it. But it's funny because then my PhD was in the ultraviolet, and then I literally went from radio to infrared to the optical and then to ultraviolet. So I managed to study a little bit of all the spectral energy distributions, of stars and galaxies. But basically, yeah.
Your
So
your PhD was in the University of São Paulo in Brazil.
yes. So it was the University of São Paulo, as was my undergrad study. Sorry, my master's degree, and then my PhD. And then yeah, with the experience I had with my master's studies, which was then it was studying the SEDs of galaxies in both the optical and ultraviolet. Then I stumbled upon a problem which is called UV upturn of galaxies, and that's when I thought it was a very interesting problem. I didn't see many people doing that at that time, and then I approached Paula about it, and then we wrote a project together, which was a cool thing. So I had the experience to write the project, my PhD project with Paula, and not to start a project written by somebody else. That was a very cool thing, and I think also as an for my own experience, it was a good thing that I did. It was good for me.
Paula Coelho, who's a professor at the University.
Yes, Paula Coelho, yes.
Fantastic. Things that you and I know because we've been knowing each other for some time, but people who are listening to this interview.
You're right. You're correct. Yes. Good. So this.
You came up with your PhD project yourself. I didn't know that.
Yes. So I kind of did bring my PhD project myself, and I was happy that Paula embraced it. She wasn't trying to change it or to propose something else. She liked it. She actually, at the time, I remember she told me that she always wanted to do something, study this phenomenon somehow, and she never had the chance. So it was a cool thing.
This phenomenon, me and the people listening.
Okay, so I'm gonna explain the UV upturn to you guys. So the name is very fancy, but the problem is somewhat simple. So the thing is, the ultraviolet is a very energetic range of the electromagnetic spectrum. So for stars and consequently galaxies to emit in the ultraviolet, it means that you need hot stars, mostly young stars. So young and hot stars, they emit strong ultraviolet. So the problem is that you expect this ultraviolet, thinking in reverse now, you expect this ultraviolet to be predominant in galaxies with strong star formation rates, with young stellar populations. And you don't even have to think about galaxies. You can think of stellar clusters, even in the Milky Way if you want, even in the local, in the solar vicinity, there are cases. So, and the thing is that we find this ultraviolet emission in systems where the stars are kind of old and cold. So this is why we call the upturn, because we see this in galaxies that are old, and usually in this ultraviolet part you would have no emissions, it would be dead, and then you see this rise again in the flux. So when you see this, you call it upturn. Well, it was going down and then suddenly it goes up again, and then it's caused by these stellar populations that we have some ideas which ones they are, but no strong conclusions have been made yet. Like, we have some ideas, but this is a problem far from being totally resolved.
When did this problem arose?
You mean historically?
When I was an undergraduate student, I don't think I was exposed to it. So is this a modern thing?
It's not that modern. So actually, this has been detected for the first time, if I remember correctly, in 1968.
Wow.
By the it's on a paper by Code, 1968 or 1969. I wrote this on a paper, so it was the first time they reported this. And it was, they detected this in the bulge of Andromeda. So the Andromeda galaxy, so for the viewers of your channel, this is the closest galaxy that we have to the Milky Way, that is in the Milky Way size, more or less. So it's a Milky Way type galaxy. Mm-hmm. It's a disk galaxy, and it's in the local universe. It's very close to us. And someday there is this expectations that the Milky Way and Andromeda will merge. So this is the history behind UV upturn. So it's not such a new problem, but it's poorly understood because unfortunately we still don't have good enough models in terms of stellar populations to really figure out which stellar populations are causing this. And of course this can vary from system to system, from galaxy to galaxy. So this doesn't mean that all galaxies with UV upturn will have the same stellar populations causing that. So I don't know if I've made myself clear. I hope so.
But after you came up with your project for your PhD, you successfully defended your PhD during the pandemic, if I'm not mistaken.
Yes, I did. So then I did my PhD. We discovered some very interesting things. And in science, what happens is that you answer a few questions, but you have tons more that appear, so you start asking other questions. So so I held on to these questions. I still have them. And then I went to do my first postdoc, which again, I entered in somebody else's project, and then I completely changed what I was doing. I was no longer investigating the UV upturn. I went, I started to do some investigations within the Milky Way, so we call it galactic archaeology. We study the stars in the Milky Way in the level of, group of several stars together. We're not studying individual stars in detail, but we're looking at them in a general way, and this is why we refer to them as populations. So I started to study them and did some very different research, but I have ideas again how to connect those things. So stay tuned.
So how do you come up with ideas on how to connect the dots? Because you don't come like the
yeah.
Game like 1, 2, 3. You're supposed to come up yourself.
Yes, of course. That's something that comes with experience. It doesn't come like that. You don't just connect things that fast. I think just true geniuses can do that really fast. But I think I failed to answer your previous question totally. So after my first postdoc, then I went to second postdoc, which was in the same direction, in the sense that I had to work on somebody else's project. And then now I'm in my third postdoc. I put together these questions that I had before from my PhD times to submit a project that was successful here in Chile. And now I'm wrapping up some things that I have been doing the past few years, but pretty soon I'm again going to investigate the UV upturn. I'm starting to investigate it again now. So this is how I think we develop ideas for projects, and then we connect the dots. Is to have to start somewhere, usually by somebody else's projects, and then you start asking questions yourself. And then at some point you may work with something completely different, and then you may ask, I don't know how people's brain works. That's not my field of research, but somehow you start to connect them, and you start to see that you can actually investigate previous problems in different ways. So I can give you an example. So one of my ideas, so if I'm studying the Milky Way, and actually I'm studying now in my groups of my sample of stars, we have stars that are cold, they're old, right? And who knows, maybe they have UV emission, but we're not checking them yet. So this is what we're going to do very soon, check their UV emission. And there have been some papers that have detected these stars that have UV emission that are like this in the Milky Way, and they seem to be blue stragglers. So they're binaries, which we also think are causing the UV upturn. So I think now the idea is, let's check the blue stragglers. There's something there to be done.
So that, has it ever happened to you that you read one specific paper and you go like, oh damn, there's something here that if I do something slightly bigger or a small thing, it can open a wide amount of research?
Yes. And I think it happens even more when you're watching other people's presentations, because the way people talk about their project is different. When you compare to the way they write about it, when you write a paper. Of course, when you write a paper, you can have many ideas. But I feel that this aha moments happen to me more often when I'm watching other people's presentations, because I can see maybe, I want to say holes of the research, but it's not the holes. It's like the opportunities. It's more like opportunities behind what they're doing. So I think, at least for me, this is how I have more ideas. Yeah. What about you? Do you feel the same?
I think so. There are some specific people who really brighten me up. Well, like, I finished that presentation, I literally feel the urge of rushing back and start doing stuff. possibly one of the most interesting things I've ever done is I was actually reading a paper. I was like, this has to be done because this brings to something which must be done. And eventually, I did it, and I never managed to finish.
But you may still finish it.
Yeah, eventually we'll finish. So actually, related with moving forward, we're in a period of explosion of new projects, especially for you young people. You guys have the chance of jumping on all these new projects which will start working in 5, 10, 15 years, 20 years. Is there any project of the next, say, 5 to 10 years that you're looking forward to?
So there are several. Some of them are really in this very near future, but some of them are even more, in my opinion, are even more exciting. They're coming in the span of maybe 15 to 20 years. So in this span of more or less 5 years, we will have the Vera Rubin Observatory, which will carry the LSST survey, which that's going to be very exciting for all fields of astronomy. We're also, in my case, I'm also very interested in space telescopes that are going to be launched. But before I talk about them, I wanted to also mention the Extremely Large Telescope that has been, a project that since I entered astronomy, 15 years ago, that I started to do some level of astronomy research. It was an undergrad. It was pretty much discussed. It was a huge project by that time already. People were talking about it, in conferences and seminars. And now we're gonna actually see it happen, and that's gonna be awesome. I think that to be alive in this day and age, to see, for example, the Extremely Large Telescope. Yes, this is what it means. The LT is the Extremely Large Telescope. Together with the JWST, even Hubble. I mean, to live to see these instruments, it's amazing. So, and then we'll have these new also space telescopes that, to me, they're very interesting because they're in ultraviolet. So for the people out there, the ultraviolet is very hard to observe because you have to go to space. You cannot observe from the ground unless you observe objects that are very far away. But if you want to observe the local universe, you have to go to the space because our atmosphere blocks this UV ultraviolet, that we want to observe. So Canada is going to launch Castor, which is their space telescope, is their consortium. So it's going to observe in the ultraviolet, and as far as I know, it's gonna more or less substitute Hubble in some ways, and apparently they will have a proposal scheme, so people that are not from Canada, they can also propose projects and have some observing time. And then after that, and then I think maybe in 15 to 20 years, we'll have LUVOIR that's going to observe from the infrared to the ultraviolet. So, and that's also, of course, going to be a space telescope. And that one is apparently going to be a big deal because it's going to be a big telescope in space observing in a large range of the electromagnetic spectrum. So that's going to be very, very, I think it's technologically challenging to do a telescope like that. It's going to be a huge endeavor. But if it is indeed, built, it's going to be amazing. I think that these large space telescopes, they're very good for that. Just like the James Webb Space Telescope. It's very good to observe planets. So I think that, I'm not sure, I'm not involved with the construction of LUVOIR, but I think that it's probably going to be the kind of instrument that you can use for all sorts of different areas in astronomy. But of course, it will probably have its own program for planet observation. I think so. Is there any, new instrument or project that you think is gonna come up that in the next few years that I have not mentioned that you would like to mention? Because we have a lot of them.
We have a lot of them. I'm trying to be conservative lately. So
okay.
Now I'm actually getting more and more excited about. I'll say it. Just say that.
No worry. Take your time.
Optical interferometry.
Oh, yeah.
I work on mostly relatively bright stars. Right? So with optical interferometry, you can have basically an optical telescope, the equivalent of an optical telescope, which is 100 meters across. And the last few weeks, there have been a series of papers showing the surfaces of some nearby stars, naked eye. So that is something that I have my eyes on a lot, and I badly need to learn more. And
yeah, you're totally right. Yeah.
Everybody's on ELT and LSST. So
it's funny. I don't hear people talking too much about ELT. They're building it, but I think people talk more about LSST than ELT, in my opinion.
LSST is literally around the corner.
Yes.
LSST is having its first light by the end of next year, if I'm not mistaken.
Yeah.
And ELT for optical astronomers is going to be a little bit more, it's a bit further away. So I guess that is a little bit, that is one of them.
2027 or 2028, more or less. That's what I saw.
I think first light
something
is
like that.
27, 28, and the first optical instrument I think is supposed to be Mosaic, which is the first half of the 2030s. The first instruments are going to be near infrared and mid infrared instruments.
Yeah.
So for us optical astronomers, optical going towards the blue is like, okay, so we can relax a little bit. These are the people who have their own science cases more towards the infrared, so they get excited before us, and then,
yes.
But we're supposed to get ready. The Mosaic group is very big, very active. So if you have any ideas for the ELT, there's a vast community to contact.
Yeah, totally. I should definitely look into that. I think now that you mention interferometry, there are a few instruments that are coming that are not in my field of research, but are exciting as well, like Luiza, which is going to detect gravitational waves, from space, which we don't have yet. So that's going to be very, very exciting too for those people, I guess. Even for me that I'm not in the field, I think it's going to be pretty cool.
Luiza is expected to be launched in 2035. So don't hold your breath.
It's like LUVOIR. It's like 2035, 2040, but I'm already have my eyes on it because, you start your career and they're, just like the example of the ELT, you start your career, they're starting to, sometimes the project is already very advanced, but it still takes 15, 20 years for that to come out. And then when that comes out, you start new projects. You start working on them, and probably when they come out, you'll be, in the best case scenario, you're going to be retired. In the worst case scenario, you're going to be dead. You're going to leave it, for your students, the researchers you formed, I think. So.
Well, you're still young. That you are.
Well.
Let me tell you, you are. So, in this sense, let me ask you this. How do you think, when you entered into astronomy like 10 years ago, the 8-meter class telescopes from the ground was something relatively novel, and even 10-meter class telescopes were relatively novel. We are moving now towards a survey telescope of 8 meter, a lot of comparatively big spectroscopic survey telescopes in the order of 4-8 meter class. And we're building 30-meter class. And since I know that you are into the data science kind of world, 20 years ago, that there were just 2 or 3 freaks who were doing some machine learning kind of thing. Now is super big volume. So I guess my question is twofold. So how did you see astronomy evolving in these 10 years since you started until now? And how do you see astronomy changing, if anything, between now and the next, say, the next decade?
Yes, well, that's a tough question because honestly, astronomy, I feel it's changing very fast. So I think that what we have seen in the past, say, 20 years, I'm going to say 20 years because this is important. The last 20 years is when we actually saw the power of all sky surveys with, for example, the Slow and Digital Sky Survey, which started, before the year 2000, if I'm not mistaken. I don't know, 1998, 1999, more or less like around that time. And it's still ongoing. So we are in 2024 today. It's still ongoing. And people use it every day for their science cases. So before then, we had, and it's funny because a lot of the most important seminal papers we have in astronomy were done with tiny, observations of small amounts of stars, small amounts of galaxies. And a lot of conclusions were, people, really discovered many of the basic concepts we know in astronomy with, small scale observations, which is amazing, I think. But now we're going deeper and we're starting to find very interesting things. So we have this changing for the survey area that we saw in the last 20, 25 years. And now we're going to move, I think, we're advancing different fields in different ways. So what I mean is, for example, with the James Webb Space Telescope, that, people are still talking a lot about it, but it's really amazing because we're actually starting to see deeper in time, in the origins of the universe. And I just came down from the IAU meeting, from the General Assembly. So for your viewers that are watching this is the largest meeting within the astronomy community that happens every 3 years. So people come from all around the world to meet and present their work. And what I've seen there is that people are actually finding out that the reionization epoch apparently happened earlier in time after the Big Bang. So you have like very fundamental things that we thought were true changing in real time today, like in the span of 1, 2, 3 years. So we're actually, sorry.
I remember when I was starting my PhD, when I was doing my PhD, and slightly after, the reionization was supposed to be between redshift 8 or 6. And I understand that now there's a consensus, it must be redshift 14, 10.
I think, I'm not 100% sure about the redshifts. What I heard in general is that it was around 6. Yeah. But it apparently is around 9, redshift 9. That's what I've heard. So we pushed back quite a bit. But this needs to be verified by the people of this field. But this is more or less what I've heard. I wrote it down. So this is the kind of thing we can expect to see, I think, in the next 10 to 20 years, is that we'll see deeper in time, like in these epochs just after the Big Bang, and then we'll actually get to know about this. And then, as I told you, I think we're seeing different things in different areas. So again, we're going to have more observations, for example, in terms of planet atmospheres. We will be able, I hope, that we will detect exomoons as well. We have, as far as I know, we have never detected exomoons so far. So this is something people are working on. And why do we care about exomoons? Because people may think, why do we care about it? So there's this whole theory that, for example, in case of planet Earth, that to be habitable as it is today, it needed some sort of a stabilization of its orbit, which is only possible with the moon that we have. So So we have a somewhat stable orbit around the sun, and we have a very slightly tilted, axis, which is a good thing. We're not like Uranus, which is almost 90 degrees tilted, which is, half of the planet is day 100% of the time, and half of the planet is night 100% of the time. So we have this configuration that is only possible because we have the moon that stabilizes this orbit. So people are looking into exomoons also in this direction. So if we have exoplanets, we also need to see if they have exomoons, because they are important. So if we want to find life in Earth-like planets, for example, a moon is important as well. So we have these directions of research that are totally different, in planetary science, in the formation of the universe. So we have all these fields like expanding a lot, and I think we can expect to see these things in the next few years to increase. And I'd like to know about you, if you agree, or if you want to add something, if you want to change something.
I wasn't ready for this.
Okay.
Actually, you picked up two fields from which I am very much disconnected. So I'm actually...
Me too. Me too. But I'm very excited. I mean, I'm curious. I think I want to know what's happening.
So yeah, and I was not at the IAU General Assembly in Cape Town. But yeah, for me, that I'm digging inside my own research field. So we have a series of big questions in the world of cataclysmic variables, and like now we are all waiting for the explosion of the Corona Borealis, which has been unfortunately big news.
Yeah.
Too much on the highlights for the last few months, and I've been around for too long to get too excited about this. Why some objects explode regularly, some objects don't? What drives some sort of stellar evolution and what doesn't? So I am at the moment much more focused in my own research field, and I have some curiosity, and I am sort of excited about some specific technological development, like the astrophotonics universe. So they're basically managing to reduce instruments which would be as big as a table to a machine. That is just, for me, it's mind-blowing.
Yeah.
If you could pick up one question for like the next decade that you would want to focus on.
Oh man, I can't do that because yes, it's true. I have my own research fields in the plural because I have been doing different things, but I think there are very exciting things that are going to happen outside my research fields as well. And it's very tough to just pose one question. I think I cannot really do that. I'm unable to do that.
Let me ask. So I know that you've been involved in the astrostatistics / machine learning. Let's call it collectively artificial intelligence at large. So since you're more expert about artificial intelligence and machine learning than I am, can you give us a feeling of what you think artificial intelligence is doing and can do in the next years for astronomy at large, or if you prefer, just for your field?
Wow. Yeah. Okay. I don't think I'm more in artificial intelligence than you, but it's true that I have an interest. Well, I think we can expect the unexpected, honestly, because if you think in general what we've seen in society in terms of ChatGPT, image generation, video generation, everything that is going on, those things are not disconnected from astronomy. So we're going to be also pretty much influenced by these algorithms, and people use it a lot today and are going to use it more and more. in the years to come. And I think this is going to be very important for several reasons. So, as we have been talking, we know that we'll have a huge amount of data coming from all sorts of instruments, from all sorts of observations. We already have a lot of data. We already do, and are going to have even more. So how do you dig into this data without artificial intelligence at some point? You will need it so you can treat this data, filter this data, and use this data in such a way to optimize your research. So the more data we have, the more artificial intelligence we'll need. And this is good. This is for sure a trend that is being incorporated, more and more into astronomy. The only problem I see with it is that, of course, you may just have issues with detecting things that are not what you think they are, and because everything is automated. But, there are other issues also at play that are not so obvious to most astronomers. For example, we're using today basically a lot of stuff like deep learning for problems that you don't really need deep learning. There's also a problem in my view because you need to interpret what you're doing. And to do that, consciously, maybe you need something simpler. But that, and I'm not saying to do square fitting, which is what people used to do, a lot in the past and still do a lot today. But you can use something that is more sophisticated than that doesn't need to be as sophisticated as something like deep learning. And it's going to give you the same results, but with the interpretability that deep learning doesn't give you. Yep. So there's also this side that people are just basically bypassing. They're not looking to that, as they should. And that's the problem because astrophysicists have not been trained properly in statistics and machine learning. We have not been trained to do that. We have to do that on the fly, and then you learn some technique and then you apply. But just basically, that's this thing called deep learning. Let's use this to do whatever we want to do, But I think it's also a literacy problem, and that's also a problem in society and astronomy and maybe all fields, because we need to be also literate, in these techniques.
I have just two last questions because
okay, sure.
So one is actually related. So I wanted to ask you in one order, but I will reverse the order because basically you put it up. So what advice would you give to someone who's interested in a career in astronomy? Okay,
so maybe I'm gonna be anticlimactic in this question, because I think that maybe not only in astronomy but in academia in general, it's very tough to build your career because there are several challenges that you don't know when you're young. And when I mean young is when you're an undergrad or when you start your master's or even your PhD. These are challenges that you have to face, like for example, applying to grants or applying to positions. You have to apply to a lot of them, and sometimes you don't get an offer. It may happen you don't get an offer, and then you may be unemployed. So I think that my suggestion is you can go to your research field. You can do your research and learn the skills that you have to learn, and learn how to apply them, say, in the real world. I mean, for a job, for say a data science job, or if you're doing some research in another field, like, I don't know, pharmaceuticals, you can use that in the industry. I think it's important for us to be open-minded about maybe not being able to pursue a full career, either in astronomy or even other fields, because it is really tough out there. You don't know who you're competing with. So for someone like me that did my PhD in Brazil, maybe there's a position that I'm competing with someone who did their PhD in Harvard. Who knows? I'm not saying my PhD was worse, but whoever is reviewing my CV will think my CV is worse. So and this is so you have to be open-minded about, changing careers if you have to. So, astronomy is very interesting, it's very exciting, but the system is really rough. So you have to be prepared if you want to stay, and also be prepared to leave if you have to. I'm sorry, maybe that wasn't the most upbeat thing, but it's the truth.
Yeah, that was tough, but it was true. Saying by someone who's been, I have considered, and I was on the verge of leaving astronomy at least a couple of times.
Yeah.
So the last thing I wanted to ask, just maybe to cheer us up a little bit, just to close.
Okay.
One or two memorable moments. If you had to pick up, your career is short. So, but still, one or two memorable moments of your career.
Okay, that's, I can say the obvious. When I defended my PhD thesis, for example, it's memorable because, it's the moment that I officially became a scientist, I think. I can say that. Or that I was validated as a scientist. Maybe that's a better way to put that. But I don't know. In terms of just, being in an environment that was very, memorable. Recently, the IAU in Cape Town was pretty memorable for a series of reasons. It was the first time in Africa. So I managed to talk to a bunch of people, see some wonderful music presentations. I think that was pretty memorable, and it's not totally, it doesn't stick totally to the research itself. But being part of, these events sometimes can be very nice. I don't know. It's tough for me in terms of maybe scientific findings that I witnessed in my career. These were not my findings, but they were very exciting that I was able to witness that. So there are a few. For example, the detection of gravitational waves for the first time, that was pretty exciting. I saw this in during my own career, in my lifetime. I saw the first picture of a black hole. So that's something, even if you're not a scientist, it's awesome to be able to see that. It exists, but to see it, it's pretty awesome. The detection of the Higgs boson was also something that happened somewhat recently. So these things that you learn, you hear about, maybe you're young, and then you get to see it. It's pretty cool.
So there's something you told me about the excitement of being at the IAU, of being the scientific excitement that you had when you were flying back.
Yes.
Can you elaborate on this for us? Or can you say it here instead of message on WhatsApp?
Of course. Okay, maybe this is something that maybe it's a little taboo, but I'm gonna say it anyway because maybe we have to break these taboos. So we have a more healthy environment in academia. So I was very excited because it is the first time in my life that I felt I was amongst my own people. Like I could talk to people. I could look them in the eye and talk to people I don't know, and exchange some ideas and ask for advice, and I don't know, maybe build a project together. Because before this moment in time, I did not have my own project. Of course, I had this when I was a PhD student, but when you're a student, you're a student. But now I have my position that I got with my own project, and there's this, at least to me, psychologically, something shifted the way I interact with people. So I think I'm very excited. The whole meeting was fantastic, but also I'm excited that I finally reached a point that I feel safe enough, I feel confident enough to approach people that in other contexts I wouldn't be able to do. I wouldn't be able to approach. So I think it's a little taboo because we think that people should be able to talk to anybody at any moment, but it's not like that in real life. You get, you feel a little weird talking to somebody you don't really know, especially if you're young, a young researcher. I mean, who are you? You're talking to me, I'm this fancy person, researcher. I mean, I'm not saying these people think like that. Maybe some do for sure. But that's what happens in your own head when you're a young researcher. Like, what this person's going to think of me? I'm this random person talking to them.
I'm not trying to ask a question to a full professor who's been in the field for 30 years.
Exactly. So this mindset, like this psychological shift really happened with me now. I hope it sticks. And because I don't know. That's it. And I think this is also a huge part of my own excitement coming from the IU. And I mean, the IU itself was, it was in Africa. I had never been to the African country, entirely. I had never been there. So it was my first time there. It was amazing. I really, really enjoyed it. Maybe it was the best conference of this format that I've been, that I really, really enjoyed. I mean, it's my favorite one for sure.
Did you eat springbok?
I didn't. I'm sorry.
Did you have South African wine?
Yes, I did. They're very good. Yes. I had them before too.
Yeah, but there is the place where to have it.
Yeah.
Did you go to Cape of Good Hope?
No, because I probably need a car, and I
didn't have an excursion to go there.
Maybe there was. I honestly didn't check it out. I mean, the weather wasn't fantastic. It was rainy, windy. It was kind of tough to go out in the few days I had free there. But it was worth it anyway. I mean, was able to see Table Mountain from afar because it was closed, but I did see it. I'm happy about it. Saw a bunch of nice music presentations. So I saw seals. So I think it's not so bad.
Table Mountain is the only place of Earth which is amongst the constellations. The constellation Mensa is named after Table Mountain in Cape Town.
Yes, I saw this discussion when I was there. It's really cool. It's really cool.
People of Cape Town, at least the astronomers of Cape Town, are very proud of it, with good reason. Yeah. It's actually quite an impressive view.
Yeah, it is. And it's so beautiful when the sun shines over it. I don't know, the colors, the whole thing. I don't know, it's pretty magical. I agree with you.
Awesome. So, Malu, thanks very much for joining us.
Thank you for the invitation again. Thank you for your viewers. And I hope you enjoyed this conversation. And maybe you learned something nice, something cool you didn't know about. And maybe see you some other time. I don't know.
I hope to come to visit you in Chile sometime soon.
Yes, please come. Maybe I'll come to Spain. Who knows?
Very much looking forward to have you here.
Cool.
So, I hope everybody got bored with this conversation. You may notice Malu has had very short career so far. So hopefully she has more time to go. Notice she prepared her PhD project herself, which is quite unusual, but that was quite an interesting challenging. There's a lot of talking about optical, and especially lately with JWST, there's a lot of talking about infrared. Malu's primary wavelength range is ultraviolet, so don't forget ultraviolet. And one of my favorite bits of the conversation was when she commented that astronomy is changing fast, and she brilliantly commented the event of 20 years ago, the Sloan Digital Sky Survey, and all the fancy and nice projects which are happening now the next 10-20 years. I love the expression, we can expect the unexpected from the artificial intelligence. For the ones who are considering joining this universe, I think it was a very interesting message to keep learning and do not be afraid of changing field if needed, even if it's leaving astronomy and move to the real world. So Thank you very much. I hope you got bored, and talk to you soon. Ciao.